Today, our topic is Simcenter Femap version 2020.2. What's new? Just so everybody knows, it was actually released and can be downloaded. It was released last week, so it can be downloaded from Siemens Digital Industries GTech now. The Femap direction, I'm not going to spend a whole lot of time on this. I would imagine most of you are familiar, but as of this year, it's now 35 plus years dedicated to the needs of the FEA analyst. We basically, we cater to the analyst community, much more so than the design engineer. We're more for the dedicated analyst. So these are just some of the things that we do to maximize efficiency and build upon the Femap capabilities. And one of the real things to remember here with the capabilities is most of the capabilities we add are also available via our Femap API, our applications programming interface. So anything you see here should be available through the API as well. So you can use that to write some customization and anything like that. Just so everybody knows, if you haven't been on one of these in a little while, we've moved to a 6-month release cycle. When we switched to a kind of yearly numbering scheme, the first one of which was 2019.1, we actually went to a 6-month release cycle instead of a yearly release cycle. So essentially what you're going to see every 6 months is you're going to see a feature release, and then you're hopefully going to see a maintenance release if required. There's almost always going to be at least one maintenance release. You'll notice it'll just be called like MP1, and then if it's needed again, you'll also see another one that's MP2. For instance, 2019.1 only had an MP1, but 2020.1 had an MP1 and an MP2. They're typically going to come in April, October, or you can just think of it more as sometime in the spring and sometime in the fall. That's sort of how it's worked out. The maintenance, so the feature releases have new features, expanded functionality, database changes, API expansion, and a lot of times, well, they'll always require a licensing update and maybe a localization update if you're using Femap in a different language. The maintenance releases are all bug fixes. We even have kind of moved away from even putting minor enhancements in there unless it's behind the scenes. So there will never be a change in the user interface in a maintenance release. So Femap 12 was October 2018, 2019.1 was last April, 2020.1 was last November, and May 2020 is when we released the one we're going to talk about today. So without further ado, we're just going to get into this. So one of the big things that we did for 2020.2 was just performance improvements. So if you're using the connect automatic command, we made it 3 to 5 times faster when we're making a large number of connections. For copy, rotate, and reflect commands, whether you're doing mesh or geometry and the move commands, we made this noticeably. We basically do only a version of a rebuild when we do these commands, just of what's needed in the database. And in certain cases, when you're in large models, when you're copying small portions, you might see up to a 40 times performance increase. Just 2 to 3 times faster when you're putting length-based mesh sizing on curves. A lot of commands in Femap are actually waiting for an abort. Unfortunately, one of them is not meshing, so but we have certainly looked at that, and maybe we'll implement that at some point. But we were checking for an abort quite a bit in a lot of commands. So just by checking for this less, we basically got either anywhere from a 2 times to 100 times performance improvement in those commands. Now, it will take a slightly longer time to react depending on what type of command you're doing, but for that type of performance increase, waiting another second or two for your command to abort shouldn't be a problem. If you're using envelope, linear combinations, or RSS combinations, when you're doing output processing, we got about a 30% plus improvement in all of those. Nastran model read, which was already kind of really fast, we improved that by almost 2 times when importing large input files. And for anybody out there using ANSYS, when we're reading the results, we got about a 2 to 3 times speed improvement when reading the results from the non-compressed RST file, so the results file. Just in performance graphics, this was just an example of entity creation. It minimizes the free face evaluation and minimizes the full graphics regenerations. So again, it just sort of does what it needs to do. If you were creating a single entity in this model, this already large model, so we created a single rigid element and a 3.3 million noded tetrahedral element. It took 29 seconds in 2020.1, and now it takes 0.3 seconds for you to create that element and for it to appear in the screen. So almost a 95 times performance improvement. There's also some improvement in copy in large models, but not as significant as in creation. So if you're copying existing entities in a large model, there was a pretty reasonable improvement there as well. Just some other things that we added. We added an option to do a full regeneration every time, or actually do a full group evaluation every time you do a Control G. Every time you do a regeneration of the graphics window. That's off by default, but you can turn it on in here. And also added the ability to disable abort in commands. This can also speed up certain commands. Added, for a long time when you had best possible turned on or basically we didn't allow you to set the VBO values there for max VBO and min VBO, even though performance graphics uses them. So we basically just ungrade them and now allow you to choose them even when you're in best possible. For UI and visualization, so anybody using 2020.1 probably noticed that we changed every icon in the program. They were all redrawn. The colors were selected to enhance the contrast, making it easier to select. They used a consistent theme throughout Femap because they were all redone at one time, and they were designed to maximize familiarity and minimize the learning curve. As you can see, the old ones on the left here, and then the new ones on the right. So for 2020.2, what we did, we actually created 3 different sizes of each icon. So they were all drawn at 3 different sizes, 100%, 150, and 200. So now that these are in there, what this allows us to do is this allowed us to do UI scaling, like user interface scaling, and full high DPI support is now available. So if you're using a 4K display, Femap's now doing the scaling, not Windows or scaling's not being done. So Femap's now doing the scaling itself. So as you can see, when it was disabled, the icons and text could be small and hard to read. When it's handled by Windows, it could create blurry text and icons. But essentially, now when you do our high DPI aware, which is the default, you're going to get what you see on the left here. And these are just kind of 2 examples of the same on the same monitor with the Windows native scaling and no scaling at all. So again, if you're using 4K monitors, this should be a big improvement to what you're seeing in Femap. Another thing that we added was the ability to do curve connectivity. Essentially, it's just a way to overlay some colors on top of curves to know what's going on, like how that curve is connected to another, how the surface using that curve is connected to another surface. So you have 4 options in here: free, manifold, non-manifold, and wire body. Wire bodies can't actually be created in Femap, so the only way you're ever going to see them is if they're imported. So we're going to focus on the other ones, which are free, manifold, and non-manifold. So it's just an option here in View Options. And what you do is you can pick and choose your colors if you like. So that's you just click that button and choose which color you want for which type of curve connectivity. And you can also turn this on and off via the View Style menu on the View toolbar. I'm actually just going to go over into Femap here, and I just want to kind of show you this. So I'm just going to turn this on. The View Style menu. So you can see a lot of these are red. So a lot of these are showing basically that they're not connected to one another. So red means free in our particular, that's the default color. So what I can do is I can come and go to Geometry, Surface, Non-Manifold, Add, and I'm just going to pick what's visible. I'm going to say OK. and we're just going to non-manifold add this together. And now you can see everywhere where there's a non-manifold connection, that's now going to be shown in yellow. So everywhere there's essentially a T connection in our model, that's going to be shown in yellow. So it's just a nice way to tell how your geometry is connected inside of Femap. Another thing we did was just renumbering. We just made it a little bit easier when you're using the offset options. So you basically, compress is just your standard renumber. Now we have offset to and offset by in here, and depending on what you choose, in here, the options at the top just change. So it's just a little bit easier to know if you're either offsetting to a certain starting ID or offsetting by a given amount of ID offset. Basically, every time we copied to the clipboard or saved to a file, we were always doing it in rich text format before, or just text. But now we do it also in formatted HTML. This just occurs by default. So this is just basically something that I copied using the copy to clipboard icon from the data table, and then I just got it over here into, that actually was into Excel. So all those colors came, all the formatting, all the text, everything of that nature, it just came over automatically. New technology in Femap offers the ability to transfer data from dialog boxes and panes directly to Microsoft Excel. So you'll see in various dialog boxes and panes, you're going to see a little icon that has the X for Excel. So you basically can just click that. It's going to automatically pop open Excel, and then it's going to send the data from that dialog box or pane over into Excel. So it's in the layup editor, standard entity selection dialog box. So you can just send your IDs over there. It's also in the data table, the function table editor. So in this case, this was from the data table. This was a free body listing that just came over, and as you can see, it's all nicely formatted. The rows and columns are just like they appeared over in the data table. Again, it's done with the HTML formatting. And it's also in the charting dialog box. So I'm just going to, again, I'm going to come over in the Femap. I'm just going to come here. I'm just going to show you this. So in charting, we can just come to this drop down here. So this is always where you could copy the images, values, or images and values, or you can just do send to Excel. It's going to do that. So it's just going to open Excel for me, and it's going to send the data and a picture of the current chart. So you can see it sent me my XY pairs and a picture directly over into Excel. So I'm just going to close that out and go back to the presentation. Okay. Another thing we added was this is just for, kind of a visual cue, was basically when you're dynamically rotating, you can turn on the center. And when you do that, you'll see this symbol appear. So it just kind of tells you where your rotation center is when you're every time you're doing a dynamic rotation, which can be kind of useful to know where it's going to rotate about, just so it doesn't, so the model doesn't fly off the screen or anything of that nature. We made the equation editor. Actually, we added a new option here, which actually allows you to use it to get the element corner thicknesses from elements if you need to. And we also allowed it to be so you could resize the dialog box up and down, just so you could see more of what was in these lists. Also in view options, every time you now choose view color in that, if you've chosen view color, if you've chosen the color palette to select a color within view options, when you click OK, it'll automatically switch your mode to view color, because there's no other reason why you'd want to be setting a color over in view options unless you were going to be using view color. So that just does that for you automatically now. Also, for whatever reason, select visible, which we added in version 12 or 2019.1, I forget now. For some reason, it was not available for when selecting solids. That's because Femap used to have both solids and volumes. Volumes have essentially been disabled at this point. So basically now when you do visible, you can just now use the select visible to select the solids which are currently visible in the view. Just a little bit, just a little bit of additional information when listing arcs and circles, and improve the model merge command to clearly handle cases where user intentionally chooses to override existing entities in the current model. That just wasn't fully flushed out, so now that's all. It's just much better if you're trying to use model merge to overwrite particular entities in another model. Another thing was added the ability to use commands on floating toolbars while using another command. So if a dialog box was up, before if they were docked, you could use them, but you couldn't use them when they were floating. So again, just a little bit of a limitation that's now gone. And just something, if you wanted a quick way to be able to do show full model, show active group, show multiple groups, we just added that to the commands. So you can now put them, you can have them show up on any toolbar that you might want. Okay, we're gonna go into pre-processing. Something for beams, this is a Nastran specific thing. We just added write zeros at end B. Essentially, when you have this, when you turn off this option, it basically then nothing is written to the Nastran input file for that field, which essentially in Nastran means NB is then automatically equal to the end A value. So before we would be writing zeros there. Now you have the ability to write a blank, which it just automatically makes it the same as end A. Added the ability to set the output coordinate system via tools parameters, and also specify color, next ID and increment for monitor points, and a next ID for matrix inputs, the DMIG, which are the DMIG entities that we added for 2020.1. Something people have been asking for a long time was tools, mass properties, solid properties, was the ability to pick any number of solids and have it generate a single value of mass properties for all the selected solids. So basically to select it and basically give me the mass properties for that entire solid assembly. It also used to then ask questions about whether you wanted to do, create a node at the center, create a representative mass, and then link to the mesh. All of those are now options you can choose in the dialog box, so you kind of know what you're going to be doing moving forward. So you don't have to answer a bunch of questions. So we just consolidated that into this one dialog box. Also, you can also now just automatically send the information to the clipboard. Very similar, send to clipboard was if you were doing tools, mass properties with mesh properties. Again, we just added an option in there that can automatically send the information to the clipboard, and just again consolidated the GUI a little bit. Added the ability to specify follower forces and follower moments inside of Femap. This is typically used for nonlinear analysis with Nastran. So you essentially just give it a magnitude, and then you give it either 2 points to define a vector for that load to stay, for that load to quote unquote follow, or 4 points can be specified. 4 nodes or 4 points can be specified to use the normal of the plane from those 4 points. Okay, let's go on. Meshing. So this is probably not exactly a meshing command exactly, but it's in the Meshing Toolbox, and it has to do with feature removal. So we just added a preview option to the feature removal blends operation. So when this is turned on, I'm actually just going to, again, I'm going to go back to Femap. This is probably a little bit easier to show. So I'm just going to come over here into my Meshing Toolbox, feature removal, go to blends. As you can see, preview is selected. So I just go and I'm just going to select my single solid, and it's just going to pick everything we want. These obviously aren't blends. We certainly don't want them, but I'm just going to cancel this. I just want to show you that you can also use this with limit size. So I'm just going to put in a value of about 2.5. Then I'm just going to select it again. Okay. So it certainly did grab some things that, again, we probably want to leave in the model, such as those corners. And it didn't get some. I'm not going to pick them all. but for some reason it just didn't get something like that. You know, this one in here, you know, and a couple of these other ones. Just gonna get this pocket right here. Okay, so then when I hit OK, then it's actually gonna go through and finish the blend removal operation. Okay. And just so everybody knows, we made the blend removal, we updated that quite a bit and made it a great deal more robust for 2020.1. So back to the presentation here. Yeah, we're just going to cruise through that. We also added surface replace face under the extend operation for geometry editing. This was already, so you could already use geometry solid extend within the, that was already a menu command. So again, I'm just going to come back into Femap, and I just kind of want to show you how this is going to work. So what we can do with this is we can do geometry editing. I'm going to choose extend, going to go to surface replace face. The only thing to enter is the surface to extend to, or the destination surface that I like to call it. So I'm just going to come in here. I'm just going to go back to pick front here, make this a little bit easier, say OK. So now I can just turn on the picker and just pick what I want, and you can see that this is just extending these surfaces up to my destination surface. All right. So those were sort of engraved. I'm actually going to change this now. Change which surface I want. Change my destination surface. Going to say OK. And I'm actually now just going to pick all these kind of at once. So these are kind of raised letters, and they're going to be removed as well. One more thing. Sometimes fillets and blends can be a little difficult to get rid of. So this is sort of a trick that you can do. And this is sort of kind of replace those blend faces with the destination face. So I've picked my bottom one there. So now I'm just going to come in here. I'm going to choose a fillet. I'm going to say add connected fillets. Say OK, and you can see that it was easy to get rid of. Now those would have come off with the other tool I just showed you before, but I'm just using this as an example. All right. So we'll come back into here, and these are just some examples. You can also use extend in this way. These are solid bars, and you can kind of just pick which one you want and extend them, and extend them to each other. There was a lot of commands on the mesh editing menu. They've been added over various versions. Some, have probably been in there for 10 plus years, while some others have kind of been added a lot more recently. And the ones we added a lot more recently had some additional functionality compared to those. So these are the commands I'm talking about: interactive, split, element, refine, and edge split. So what we did was we basically just took all the best features of all these commands and made them all work a lot more similar to one another than they did before. So updating nodal constraints and permanent constraints, updating loads, updating regions, updating tapered beam shapes, beam offsets, plate thickness, and material directions, updating the groups. So if an element was in a group before and it's been split somehow or edited in another way by one of these commands, it'll get updated in the group, and as well as geometric associativity as well. Just some mesh sizing things that we did. Just the consistency when mesh editing, doing mesh size on curves using element size. This was a very strange phenomenon where you could have two curves that were basically would even list out as the same size in Femap, but were ever so slightly different way down in the decimal places. So they could actually end up getting a different mesh size by one. We basically just eliminated that issue. Also, we essentially, the only way that you're going to want to make a combined curve is if that curve is being combined to another curve of a particular type. So only free edge curves can be added together to become combined curves. Only manifold curves can be, added together to become combined curves. Same with non-manifold and/or wire bodies. Post-processing, we actually did quite a bit in this area. The first thing we did was list output results to Excel. Essentially, this is going to automatically open Excel. It takes advantage of the row column control, alternate column order, and formatting style. The row and column control, alternate column order, that was all from the list output results to data table command. We essentially just reused this dialog box and changed it a little bit. You can also do transformation of output data that you're going to send to Excel, which again, that was added for version 12 to list output results to data table. And then also you can transfer nodal and/or element results at the same time. So just as an example of this, I'm just going to come in the Femap. I'm just going to go to this model. Again, it's here on list output results to Excel. It's going to say, okay, I can choose whatever I want. I'm going to leave the formatting on just because I kind of want to show you what it comes up with. And then we just get our standard selection standard output selection dialog box. I'm just going to say all output vectors. I'm going to say all elements, all nodes. All right, it's actually in reverse order there, but so this is going to open up Excel, and then you're going to see it. Then you're actually going to see it kind of populate all this data. So the nodes go onto one sheet, and the elements onto another. So now that I'm in here, I can do nodes. So you can see that I have the filtering is already built in here for each of these columns. The ID column is a frozen column. So you can see that it, as I scroll to the right or left, you're always going to see ID over here on the left-hand side, and also and all that column headers are also frozen. So as I come down, you can see that they're going to stay up at the top, and of course, you got all the same stuff over here on the element tab. Okay, so I'll just go back to the presentation. And this is just, again, column filters, frozen row heading, frozen column ID, ID column, and nodal and elemental results on different sheets. For anybody doing aeroelasticity, we added support for aero pressures from static aeroelasticity. Again, these results are only in the FO6 file, so that's something good to know. But the neat thing about this is that we're actually now able to contour and criteria on the aero mesh of aero panels or aero bodies. So we added support for aero pressures, aero coefficients, and aero forces as well. So those are the three things we added for aeroelasticity support. Hopefully, some of you have started to use solution 401 and/or 402, the multi-step nonlinear solutions inside of Simcenter Nastran. Anyway, so we added support for shell thickness output. This is actually only in solution 402, but anything being something like being drawn through a hole here is going to thin out as it deflects more and more. So basically, you can now have a plot of that. The other thing that we did, this was actually done in a maintenance pack for 2020.1, but we added support for the plastic strain output from solution 401 and 402 as well. Another thing that we did was the results from the PF results, which is progressive ply failure. So this is in solution 401 and 402. Essentially what you do is you specify a MAT DMG, MAT damage, a material damage entry in Nastran. So we can look at damage status, damage values, damage energy, and crack density in these models. And just to kind of show you that, it's maybe it looks kind of neat in here. Is we're just going to come and choose a different. We're going to choose one of these. I'm just going to use this damage, solid cohesive damage. And as you can see, you can't really see it until I do a deformed model. And what it is these results are only on the cohesive elements. So I'm just going to say, I want to turn off my laminate solids. So, and if we were to animate it, you can kind of see this is where the various layers, the solid, these solid laminate elements are pulling apart from one another here. So this is just some damage results that you can see. Okay. All right. Another thing, and it's kind of odd, we didn't have this before. Certain solvers will calculate top, bottom, and middle stress strain results, but some don't, including Nastran by default. So what we did was we just added an option to compute averaged mid stress strain. We had an API that did this, but so we basically just took what that API did and brought it natively into Femap. So you just, it's on the results tab of file preferences if you want mid stress strain results. And essentially what you end up getting is just these output vectors in the 8,000 range, which represent an average of the top and bottom. Now, if your top and bottom results are not actually at the top and bottom, there's nothing we're doing to take that into account. So if you haven't requested them at the top and bottom of your plate, you're still just getting an average of the two values. So we're not taking into account if they are not at that position. So that's kind of on up to the user. And it's also not supported for complex results, just so everybody knows. Stress linearization, again, if you've been using Femap a while, and especially if you've ever done any sort of work with pressure vessels, hopefully someone has sent you the stress linearization post-processing tool that we had. We just brought that natively in the Femap. So it's just based on ASME boiler and pressure vessel code, this particular section. It calculates a linearized membrane, linearized bending and peak stresses along a stress classification line. And this is just the tool inside Femap. So essentially you just pick you basically just pick the two nodes and then does the calculation, and you get this nice graph that shows up. This is just a little bit of background about it. Very, very important to talk about when you do this is choice of the stress classification line is critical. So if you are doing this type of analysis, you absolutely need to know what you are doing in order to make sure that you're picking a proper SCL. Otherwise, the results you get out of it may not tell you what you think it's telling you. Yeah, I'm just going to kind of come out of here. And I'm just going to go back into Femap real quick. So I'm just going to come to this model. So you're going to be able to find this in list output. View advanced post stress linearization. So we just pick an output set. If it has nonlinear results and linear results in the same thing, you can choose to use the nonlinear results instead of linear results. So then you just pick two nodes. I'm just going to pick right here. Then one on the outside, and then as soon as we got that, we can just hit calculate. And it just gives us this graph. If we want, we can do a copy to clipboard and open up Word. Well, while Word's opening, I can also just, if I had another output set, I could choose it here. I'm actually just going to come over to a different model. I'm going to do something similar. So again, I'm just going to pick one node on the inside, one node on the outside, and hit calculate. Okay, so, and here I just pasted that from my original one that I showed you, just in the Word. So you get some information, and you get it, and then you get the graph, which you can then, make larger if you want. Okay. All right. I think that's the end of me going back to Femap, so we'll just kind of finish this off with some solver support issues. The developments, not issues. One thing that we now support is the Nastran General Matrix element, or Gen L. A lot of times these are in a lot of models, especially older models, or any model where someone just wanted to essentially replace an entire component with a stiffness matrix. It's almost like an element that acts like a DMIGs and GenLs are somewhat similar but different. And so basically these just have connection points, and actually at the connection points you can actually choose which degrees of freedom are involved at each connection point. There's also a define matrix button which you can click, and it pops open another dialog box where you'll see this information, the actual matrix values. Follower forces, like I said, for Nastran, so the one with 2 nodes or 2 points is the force 1 or moment 1, and then the one for 4 nodes or points makes a force 2 or moment 2. Again, these are typically used with solution 106, 401, and 402. Just as support for solution 402, we added 2 new function types which allow you to enter true stress versus strain, or true stress versus plastic strain instead of engineering. So the easiest way to do that was just to add 2 new function types, and then it certainly also which one you're using instead of just putting a checkbox somewhere in the analysis set manager or in the material dialog box. And this is the last thing. I mentioned the mat damage before. The mat damage, this is the unidirectional ply failure material. There's also an enhanced or EUD ply failure material. So essentially you just enter your values here. Now what's key is that you also have to have a material in your model. So this is only making the corresponding mat DMG card for another material in your Femap model. And you just basically use this material ID section to do that. Yeah, we also added a new function to support the damage evolution field on the mat DMG. For ANSYS, we added some model control. So it just allows you to skip certain portions of the model when you're exporting to ANSYS, coordinate systems, nodes, materials, properties, elements, groups, or miscellaneous. So if for some reason you are writing out your ANSYS file and you don't want any of the solver commands or view settings, preprocessor commands, etc., you can just choose skip MISC, and it won't send that stuff out for you. Another thing that we did was in a relatively recent version of ANSYS, they added this compressed output file. So by default, it's actually set to compression level 1 is what they call it. Our default is still no compression. So if you write it out, it'll basically tell the solver to give you a non-compressed output file. But we also added support to be able to read the output data in those compressed ANSYS results files, which use the quote-unquote version 1 compression. And we also added a manual control section. This is the start text, end text that you've seen in our Nastran translators for a long time to all of those different dialog boxes. For LS-DYNA, we added a very similar thing, just very similar options. Also, we added the portion of model to write. Again, that was always available in Nastran, but not a lot of the other solvers. Now it's in ANSYS and LS-DYNA as well. So again, you can skip the groups, you can skip just functions if you want to for some reason, and that's just some other, once again, solver, some comments, titles, and some additional solver type control that you can have it skip. There's also now an LS-DYNA analysis monitor. So if you have Femap set up via the solvers tab in file preferences to automatically launch LS-DYNA for you, the LS-DYNA analysis monitor will monitor your job and then allow you to automatically load the results with a button from within Femap. We also added support for Abacus. This is to preserve load BC sets. So loads and boundary conditions in Abacus can sometimes be specified using a set command or a set entry inside Abacus. And if we come across one of these when we're importing an Abacus input file, what we end up doing is we end up creating a load definition or constraint definition in Femap. And we also, if you have load definitions inside of Femap, and you choose the write all groups as sets when you're exporting an Abacus model, it will send those loads and boundary conditions out using a set command or set entry instead of as individual lines in your input file. Down here in miscellaneous, what we have is this is just some mostly API stuff. API developers can now control multiple Femap sessions simultaneously. This is something a lot of people who've kind of built whole products or whole toolkits on top of Femap, they always just want to kind of be able to pick and choose which Femap they want to be connected to. This includes Excel VBA developers. It's forward compatible. And essentially, it's done via these two commands, feapp running application info and get running application. So you can basically just pick and choose. You can create like a little interface, and you can pick and choose which open Femap that you want to be interacting with. So this was kind of a nice thing, especially, again, for people who've written whole toolkits, in-house tools, et cetera, where users might have multiple Femaps up at once. Not sure why it took so long, but we actually now there is programmatic access to the file merge command. So if you've ever used model merge inside of Femap and wondered why it wasn't in the API, well, the answer is it is now. So basically, you have the ability to select the from model by name, toggle individual entity types or groups of entity types on and off, do add related, add associated, do your orientation and transformation options, other options, and then something that's actually not in the user interface is actually the ability to make patterns of merged entities. So that's just, I mean, it's that simple, just to, do import the same thing, 3 or 4 different times, in the different positions. And then stress linearization, because this object actually sort of existed in prior versions of Femap, but only we used it to make our in-house, to make that add-on tool. So we just made it a lot more robust and gave it all the functionality that is now in that stress linearization command that you saw earlier today. And okay. And then just some new API methods and new object methods, and that's it.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.